Good morning, students. Students, in our previous lecture, we completed with you the various laws of chemical combination. And we did law of conservation of mass, law of constant proportion, law of multiple proportion, law of reciprocal proportion, and the Gay-Lussac's law of a combining volume. Now, the assignment based on the numerical problem of the same laws has been sent to you. Today in this lecture, I will be discussing with you the questions given in the assignment. And in the assignment, the question number 1 is, the same question has been written for you on the board. The question number 1 is, in an experiment, 2.4 gram of iron oxide on reduction with hydrogen. What is being done? Iron oxide is reduced with hydrogen. It gives 1.68 gram of iron. Then in another experiment, 2.9 gram of iron oxide give 2.03 gram of iron on reduction with hydrogen. Show that the data illustrate the law of constant proportion. What was the law of constant proportion, student? I told you, from whatever source you may obtain the compound, it will always contain the same element in the same proportion by mass. With this numerical, with the support of the data I will obtain over here in this numerical problem, I will try to prove the law of constant proportion as has been asked in the question. Now look over here, student. If I solve this problem, it is given that there are two experiments. So if we take experiment 1, 2.4 gram of iron oxide. What is the mass of iron oxide? Mass of iron oxide. It is given as 2.4 gram. On reduction with hydrogen gives 1.68 gram of iron. What is the mass of iron obtained over here? This is mass of iron will be equal to 1.68 gram. Fine. Now, in another experiment, 2.9 gram of iron oxide. Let me say that another experiment is experiment number 2. Experiment 2. In another experiment, 2.9 gram of iron oxide. What is the mass of iron oxide? Mass of iron oxide is 2.9 gram. Gave 2.03 gram of iron. What is the mass of iron obtained over here? Mass of iron. This will be equal to 2.03 gram. On reduction with hydrogen, show that these data illustrate the law of constant proportion. So in the question, what is done? Iron oxide is reduced with a hydrogen. And the iron oxide, when reduced with hydrogen, it will result in the formation of iron. And water will be given out. Now, in the experiment number 1, mass of iron oxide is 2.4, mass of iron is 1.68. What are the components of a compound over here? Iron and oxygen. If the law of constant proportion holds good in this case, then the ratio of iron and oxygen will remain same in both the experiment. If I find out the mass of oxygen over here, mass of oxygen, this will be 2.4 minus 1.68. And this I think will come out to be equal to, if I minus this one over here. So 2.4 minus 1.68, it will come out to be equal to 0.72. Am I clear? So this will be 0.72. You may check out, student. Yes. Now, if I find out the ratio between oxygen and the mass of iron, what is the mass of oxygen over here? 0.72 gram. What is the mass of iron over here? Ratio 1.68. It will come to be ratio 1:2.33. Now, oxygen and iron in the experiment number 1 are in the ratio of 1:2.33. If I am able to illustrate the same ratio in this experiment, then the law of constant proportion will be proved. Here, if I find out the mass of oxygen in this case will be, this will be 2.9 minus 2.03, and this will come to be equal to 0.87 gram. Yes. What is the mass of iron? 2.03. Mass of oxygen 0.87. So what will be the ratio of oxygen and iron? If you take over here oxygen and iron, ratio will be 0.87 and iron will be 2.03. If I find the ratio, it will come to be 1:2.33. So whatever may be the compound composed by the two element, and whatever source may be there, whatever may be the source of formation, the oxygen and iron in these two experiments are in the same proportion by mass. So what law is proved? The law of a constant proportion. Since the ratio remains same, since ratio remains same, hence law of constant proportion is proved. Law of constant proportion is proved. Am I clear? Since the ratio remains same, the law of constant proportion is proved. Is it clear, student? Learn, understand properly, and then try to apply the concept. Now look at question number 2. Carbon combines with hydrogen to form 3 compounds. This is compound A, compound B, and compound C. So we have compound A. Then we have compound B, and then we have a compound C. Carbon combines with hydrogen to form a compound A, B, C. The percentage of hydrogen in A, B, and C are, what is the percentage of hydrogen given? They are 25. Then 14.3 and then 7.7. Which law of chemical combination is illustrated? Compounds are of carbon and hydrogen. So what will be the percentage of carbon? This will be 100 minus 25. This will be 75%. Yes? And this is 100 minus 14.3. This will be 87.7% over here. Now, in the compound C, it will be, this will be 85.7. In compound C, this will be 100 minus 7.7. So, this will be 92.3. Am I clear? Now, see student over here. What is the percentage of hydrogen? 25%, 14.3 and 7.7. I have to prove which law of chemical combination is proved. Now just see over here. In compound A, if hydrogen is 25, if hydrogen is 25, then carbon is, what is the percentage of carbon? 75. Let me fix the mass of hydrogen. If hydrogen is 1, then carbon will be 75 upon 25. It will be 3 parts. Am I clear? What have I done? I am going to fix the mass of hydrogen in every experiment. Now, in compound B, if hydrogen is 14.3, then percentage of carbon will be 85.7. If it is 1, then this will be 85.7 divided by 14.3. And this will be approximately coming to be, or will be coming to be, equal to 6. Or I must say over here, this will be 6 parts. Am I getting clear or not? Now if I say compound C, if hydrogen is 7.7, then percentage of carbon, it will be 92.3. If it is 1, this will be 92.3 divided by 7.7. And on solving it will come, I think, must be equal to 12. So what ratio? Percentage of ratio of carbons in each case, because the mass of hydrogen is fixed. It will be 3 ratio 6 ratio 12. So this will be 1 ratio 2 ratio 4. And I think this ratio is coming as a multiple ratio. When this is coming as a multiple ratio, so which law will be proved? It will be the law of a multiple proportion. Am I getting clear, student? Which law is proved? A law of multiple proportion. So, what is the law of multiple proportion? When the different mass of one element combines with the fixed mass of other element, they must combine in a simple ratio by mass. And that is being proved over here. So, student, in this first 2 experiment, we have done with you the 2 numerical problems. First was based on the law of constant proportion and second was the law of multiple proportion. Now, in the third problem and the further problem, we will try to illustrate some more examples which will illustrate the laws. Now, look at question number 3. 2 compounds each containing tin and oxygen had the following composition. The percentage of tin is given, mass of oxygen is given. Here the percentage of tin is given and the mass of oxygen is given. Show that the law of multiple proportion is illustrated by this. Now in the law of multiple proportion, mass of one element is to be fixed and the ratio of other element, that is having a different masses, must be in the multiple ratio. Look at this student over here. What is the percentage of tin? 77.77. What mass of oxygen combines? 21.23. So in compound A, 21.23 gram of oxygen, or I must say parts of oxygen, combines with 78.77 parts of tin, combines with 78.77 parts of tin. Parts of tin. If I take one part, it will be 78.77 divided by 21.23. And this will come out to be equal to 3.7 parts of tin. 3.7 parts of tin. If you take compound B, Here we have 11.88 parts of oxygen. 11.88 parts of oxygen. Combines with 88.12 parts of tin. Combines with 88.12 parts of tin. If you take one part, it will be 88.12 divided by 11.88, and that will come to be equal to 7.4. So if you find out the ratio will be 3.7 ratio 7.4, and this will be 1:2. Is it a multiple ratio? Yes. So is the law of multiple proportion proved? Yes. So I have done the numerical video which deals with the law of constant proportion and the law of multiple proportion. Now look at the next numerical problem. How much volume of oxygen will be required for complete combustion of 40 ml of acetylene? And how much volume of carbon dioxide will be formed? All volumes are measured at the normal temperature and pressure. This question deals with which law? You have done in the class 10th also, Gay-Lussac's law for combining volume. When the gases react, they react in simple ratio of their volume, and if the product is also a gas, it will also bear a simple ratio to the volume of the reactant, provided the temperature and pressure does not change. Just see over here, applying the Gay-Lussac's law. So according to the Gay-Lussac's law, if this is 2 ml or 2 volume, what volume of this is required? 5 ml. And what volume of this is formed? 4 ml. Am I clear? If it is 2, it is 5. If it is 1, it will be 5/2. What volume of acetylene is given? 40. If it is 40, so it will be 5/2 into 40. Am I clear? If it is 2, it is 5. That means to burn 2 ml of acetylene, 5 ml of oxygen is required. To burn 1 ml, 5/2, and to burn 40 ml, 5/2 into 40. We cancel this up. What will be an answer for coming? It will be 100 ml. So to burn 40 ml of acetylene, what ml of oxygen is required? 100 ml. Now, the second part is, what volume of carbon dioxide is formed? So from 2 ml of acetylene, what volume of carbon dioxide is formed? 4. From 2 ml or 2 ml of acetylene produces 4 ml of carbon dioxide. If it is 1, it will be 2 into 4, and this will be equal to 8. 2 into, it produces 2 ml of acetylene produces 1, and if it is 40, it will be 2 into 40, this will be equal to 80 ml. Tell me, student, whether it is clear or not. 2 ml of acetylene produces how much? 4 ml of carbon dioxide. So 40 will produce how much? It will be 80 ml. On which principle the law is based? It is based on the Gay-Lussac's law of a combining volume. Now look at the last question. Very easy. It is based on the law of conservation of mass. The question is, what mass of sodium chloride would be decomposed by 9.8 gram of a sulfuric acid? So what do we have? We have sodium chloride reacting with sulfuric acid to produce sodium bisulfate, NHSO4, and hydrogen chloride gas. My question is, what mass of sodium chloride, let it be X, would be decomposed by 9.8 gram of sulfuric acid to produce 12 gram of sodium bisulfate and 2.75 gram of this, and 2.75 gram of this. Fine. Now assuming that the law of conservation of mass is proved. Now, according to the law of conservation of mass, the total mass of the reactant will be equal to the mass of product. So, mass of reactant or the total mass of reactant. This will be equal to the total mass of product. Yes, this will be X plus 9.8 will be equal to 12 plus 2.75. Solving for X will be equal to 12 plus or 14.75 minus 9.8. Am I clear? 14.75 minus 9.8, and this will come to be equal to 4.95 gram. Is it clear, student, over here? So, answer will be equal to 4.95 gram. So, by which law we have solved the problem? We have solved the problem by applying the law of a conservation of mass. Now, with this, the questions given in the assignment to you has been done. I would expect you to write down all these numerical problems in the chemistry notebook so that you may understand the concept more clearly, and when you revise the work, it becomes easy for you to revise. Student, I will suggest you to please make the notes by watching the virtual videos very, very carefully. We will meet again with the discussion of the next part of this chapter. Till then, thank you.